All right, AA SL1. Today we're going to finish off 2.4, and we're going to talk about domain and range again and look at just a couple specific graphs and a word problem. So the first one I want to look at is this graph here. It's some unknown function. We don't know what the equation is. They're just giving us the graph. Remember that a domain is all the possible inputs for the function. So holding your pencil vertically, what x values it would touch. And then if you hold your pencil horizontally and trace the function, you're going to see all of the range, all of the possible outputs of the function. So if I go vertically here, the first spot that this graph touches is -5. And then it goes, as it moves to the right, as it goes this way, it touches bigger and bigger numbers, and it actually goes to positive infinity because this arrow down here means that it's going to keep getting bigger forever to the right. There's no reason to assume there's like an asymptote or something like that. And asymptotes on graphs usually are like dashed lines. So I'm going to write the domain. I feel like we did a lot of interval notation with the American and the British style last class. So I'm just going to use inequalities for this one. So for the domain, I'm going to say that the domain goes from -5, and it includes -5 because of this filled in circle right here. So this means that it includes, if that were an open circle, it would not include -5, but it's filled in, so it includes it. Domain are x's, and we're going all the way up to positive infinity. So we actually don't even need anything after that. You can just say -5 is less than or equal to x, or you could turn it around and say x is greater than or equal to -5. For the range, hold your pencil sideways, and if you trace where it starts right here, this starts at +5, and then as you trace the function, it starts going down more, and then once again, this arrow takes us to -infinity. Or sorry, that goes to -infinity in this case, not positive infinity for the range. So that means it's -infinity up to 5, including 5. So we can just say that y is less than or equal to +5. I guess I could throw in the interval notations in here as well. Like this one, x is greater than or equal to -5. That would be -5, including, excuse me, all the way up to infinity. Or the British version is those turned around brackets, remember. And then for y is less than or equal to 5, that would be -infinity all the way up to 5, and it includes it with the bracket. Or you could say -infinity all the way up to 5, including. So 3 different ways again. The inequalities and the intervals, both American and British. Next up, a piecewise function. So there's 2 parts to this. I noticed in your homework last class that some of the pictures, they did like a red arrow and a green arrow, and it was slightly confusing about what they're doing. I think they were trying to say that that's one big function, both the red and the green put together. So I thought I'd do an example like that, where you have a blue and a red, but the whole thing is one big function. So for the domain, if you hold that pencil vertically, we hit all these negative numbers that go out to like -infinity, and then we come to right here, and then right at 2, there's a hole. So it goes all the way up to 2, but doesn't include it. But then it skips over and starts again right here, and we get more and more x values here. So, get rid of these lines. The domain is going to be, here, we'll do an American interval notation. -infinity all the way up to 2, but not including 2. And then the next section is including 4 all the way up to infinity. So you guys, when you have 2 sections like this, like where there's a gap in the domain, you can either put the word "and" in between these 2, or you can use this, which is called a union symbol. For the range, if you hold your pencil sideways and look at this, like here it goes down to negative infinity and then comes all the way up, and then here it hits 2, but then once again there's a gap in the middle, and then right here it starts at 6 and keeps going all the way up to the top again. So we're gonna have to do the same thing again where we unionize the two sections of the range. So the range goes from negative infinity all the way up to 2, and it includes 2 because it touches right here on 2. Then we're going to unionize the next section where it starts at 6, includes 6, and goes all the way up to infinity. Yeah, that's how you do that. The last problem is a word problem. The path of a golf ball can be modeled by h of t equals 60t minus 16.1 t squared. I don't like it when they use t as a variable because sometimes my t's look like pluses. Where t is time in seconds. So t is time in seconds. H is the height of the ball in feet. So h is height, and that is in feet. Part A says use a GDC to sketch the graph of the ball's path. So if you punch this into your TI and then adjust your viewing window, notice my viewing window here, I'm just doing positive time and positive height. So no need to look at negative height and negative time. It doesn't make sense in the context of the problem. But at time 0, it starts at 0, and then it goes up through this path and gets close to 60, but not quite there. And then it comes down, close to 60, and then comes down somewhere between 3 and 4. So something like that. It's supposed to look like a parabola, but I think my iPad program kind of auto-corrected it to a slightly weird parabola. Anyway, part B, why is this graph a function? Well, if you look at it, it passes the vertical line test. If you put a vertical line test anywhere on here, it's only going to touch once. So we'll say it passes a vertical line test. Then part C says use your GDC to find the t-intercepts and the maximum value. So if I look at this picture right here, they're wanting to know what point this is, and what the very tip top is, like the maximum value. Now the maximum value is just going to be the y value. So we'll put a note about that. Maximum or minimum is just the y value. So it's just like, it's basically asking like how high off the ground the ball gets. And so with that, that's your y value. And that's the only thing you report out, that it got, 55 feet off the ground or something like that. I'll show you guys in class using your GDCs how to find those intercepts using your graphing calculator. But once you do find them, let's see, the t-intercepts are 0 and 3.73. So t-intercepts are t is equal to 0 and t is equal to 3.73. Then if you use the maximum feature on your calculator, you can figure out that the y value up at the top, y maximum, is 55.9. So we'll do this one together in class. I'll show you how to do it on the calculator. Then it says write down the domain and range for this function. Well, the domain is just going to be only the x values that it exists between. So the domain is here. It's 0 to 3.73. So domain is, are they using x's or t's? I'll use x's. It goes from 0 all the way up to 3.73. And then the range, if you hold your pencil sideways, goes from 0 all the way up to the top point, which is 55.9. So we'll say 0 is less than or equal to y is less than or equal to 55.9. All right, you guys, that's all I have for us today. You have 2 sections of homework, so let's get after it.